Hey guys, today we are going to learn about polynomials a little bit more, specifically how to add and subtract with polynomials, and this will bring a lot of new vocabulary that you probably haven't heard before. So we're going to go over some vocabulary and then kind of how to use it when you're adding and subtracting. So I have this little table here with the vocabulary words here on the side, and then some different polynomials along the top, and we're just going to go through each word and apply it to each polynomial so we kind of get practice as we learn the definition. So terms are going to be monomials that are separated by addition or subtraction signs. So here we have a term, and then there's a plus sign. So then 4 is its own term, and then there's another plus sign. So 5x cubed would be a term, and then here would be another term. So there's 1, 2, 3, 4 terms here. And then if we look at this one, there's a term, 4x counts as one term, and 6x to the fifth counts as one term, and they're being separated by that addition sign. So there's 2 terms here. And then we have a 9xy, and then a subtraction, a 3x squared y, and then a subtraction, and a 4y squared. So this would be a term, here's another term, here's another term. So there's 3 on this one. Okay, coefficients, these are going to be the numbers written in front of a variable. So if I look at this negative 3x squared, the coefficient would be the negative 3. Constants are kind of like their own coefficient. We really only talk about coefficients though when they are with variables. So let's just move on to the 5x cubed. So that would be a 5. And then for the x, if there's not a number written, it's like there's a 1 there, but we also want to bring the sign with it. So the coefficient on negative x would be a negative 1. And then moving on to the second one. For negative 4x, the coefficient would be negative 4. And for 6x to the fifth, the coefficient would be a 6. And then on this one, the coefficient would be a 9. On this one, it would be a negative 3. Make sure to bring the negative. And then on this one would be a negative 4. And then variables are going to be the letters that you're using in your polynomial. So on this one, it's only using x's. So our variable is an x. Same with this polynomial, we're only using x's. But then on this one, we're using x and y. So we have 2 variables. Hey, when it comes to degrees, we like to talk about degrees of a term individually or degrees of the entire polynomial. So if you're trying to find the degree of just each term, you're just going to look at it individually and see what the exponent is. So on this one, the degree would be a 2. On this one, there's not a variable, so you can think of it as being a 0 because there's not one. And then on this one, the degree would be a 3. And then on this last one, since it's not written, it's like there's a 1 there, so a degree 1. We move on to this one. Again, nothing written, that means the degree is a 1. And then this would be a degree 5. And then on this one, when you have multiple variables, this would be like a 1 on the x and a 1 on the y. To get the degree of that term total, you add them together. So 1 plus 1 would be 2. On this one, the y would have a 1 there. So if you add 2 plus 1, you get a degree of 3. And then we have just a y here, so the degree is 2. So again, if you have multiple variables, you want to add the degree to get it. So that's the degree of individual terms, but now if I want to find the overall degree of the entire polynomial, we kind of talked about this last time, but what you're going to do is you're going to find the biggest degree in all of the terms. So we have a 2, a 3, and a 1. So since 3 is the biggest, we say the degree of the polynomial overall is a degree 3. Same with this one, we had a 1 and a 5, so 5 is the biggest, so we would say this is a degree 5 polynomial. And then on this one, the highest degree was a 3 when we added the 2 and the 1 together. So the degree of the polynomial would be 3. Okay, and then the leading coefficient is going to be the first coefficient that's kind of leading the way. but we like to do that when it's in standard form. So I actually wish these spots were switched. So remember, standard form is when you write it in descending order, so you go by degree. So we want the term with the highest degree to go first. So in the case of this polynomial, 3 is the highest degree, so the term 5x cubed should go first. And then the degree 2 would go next, so negative 3x squared would come second. And then the degree 1 would follow, so negative x would go next. And then the numbers go last, so plus 4. So when it's in standard form, the leading coefficient is that first coefficient that's leading the way, you could say. So it would be a 5. And then let's put this one in standard form. So again, the highest degree should go first. So that 6x to the 5th should come at the beginning. And then since there's only 2 terms, the next one would just be negative 4x. So in this case, that leading coefficient is a 6. And then on this one, it is kind of tricky when you have multiple variables. So what you do is you actually go in alphabetical order. And so, because we have a 2, a 3, and a 2. So which of the 2s would go first, etc. So we want to go alphabetically first. So x's come before y's. So I'm just going to ignore the 4y squared, and I'm just going to compare the x's. Since this x is a 2 and this one is a 1, we want the x squared to come first. So 3x squared, and it has a negative on it, negative 3x squared y would go first. And then by default, since this one has an x, it's going to go before this guy. So the 9xy would come next. And then since this one doesn't have any x's and we're just with y's, the negative 4y squared would go last. So that one is a little bit tricky again when you have multiple variables. So just to refresh that, you want to go alphabetically. So since this one didn't have any x's, we just ignore it and we do anything with x's first. And so we went x squared and then x, and then the y squared goes at the end, even though this has a power of 2 and this one has a power of 1. I know that seems kind of weird, but just go alphabetically. But now that it's in standard form, we can see our leading coefficient would be that negative 3. Okay, and then classifying by degree. So sometimes people will say or ask you, what is the classification by degree? We have names for them. So and maybe I'll write them up here actually where we have some space. So here's the degree names. And you've probably heard some of them before. So if it's just an x to the power of 1, we call this a linear equation. And that's because if it just is an x, if we graphed it, it would make a line. If your highest degree is a 2, this is what we call a quadratic. And we've seen a little bit of quadratics before. And they make a U shape if we graph them, a parabola shape. If it's a 3 for the highest degree, we call this a cubic. Just like we say that's a cube for the degree. And then anything higher than a 4, you would just say degree and then whatever the number is. So degree 4 and so on. So when they ask you to classify a polynomial, you're going to pick one of these based on the degree. So let's go back and look at those examples. My little baby in the background. So on this first one, if I classify by degree, the degree of our polynomial was 3. So for a degree 3, we call that one a cubic. So we would classify this as a cubic. And then for this one, the degree was a 5 for our highest degree. So again, anything 4 or bigger, you just say degree and then whatever the number is. It's not very original, is it? Okay, and then on this one, our highest degree was a 3 again. Remember, so when we added these two together, it made a 3. So we would call this a cubic. Okay. So we classify by degrees, but then we also classify by the number of terms. So I'm going to make a list here again. If there is only one term, we call, let me label this. We call this a monomial. So mon means one or first. So kind of think of also Monday is the first day of the week. So mon For monomial, that's going to be one term. If there's two terms, we call this a binomial. So you can think of like a bicycle. Bi means two. And then if there's three terms, we call this one a trinomial. It's like a tricycle has three wheels. A trinomial has three terms. And then if there's four or more, we just kind of give up and don't have any special names. We just call them a polynomial. So if that's for four or more. So let's go back and classify these by their terms now. So this one was cubic for the degree, but then it had 1, 2, 3, 4 terms. So anything four or more we just call a polynomial. So if I was to describe this polynomial, I would say it's a cubic polynomial. So that's why we classify them. And then this one has 1, 2 terms. So if there's two terms, we call it a binomial. So this is a degree 5 binomial. And then this one had 1, 2, 3 terms, which we call a trinomial. So if I classified this, I would call it a cubic trinomial. So there are your vocab words, and it's kind of a lot that goes with polynomials. And then I would write these down too until you have them memorized so that you can look back at them. So maybe pause the video if you need to write them down really quick. But we are going to move on to adding and subtracting. So when adding and subtracting, first you want to look and see if there's any parentheses. If there are parentheses, you need to take care of those either by distributing. If there's like a negative, you need to distribute, or if there's like a number, you need to distribute. And then combine any like terms. So remember, like terms, they are going to be the same variable and same exponent. So an x squared and an x cubed are not the same. So you need to make sure they have the same exponent as well. And then you want to write it in descending order. So that means biggest degree to smallest degree. So on these ones, we don't have any parentheses to take care of. And then I would look to see if I can combine any like terms. So I would look to see if I have the same variables and exponents. So this is an x1, y1, but this is an x2y. So those aren't going to be the same. And this is just a y squared. So I actually can't combine any of these. So since we can't combine them, there's no adding or subtracting to really do in that case. So let's look at this one. We have a 6x squared, a 3x squared, a 4x, and a 2. So these are all x's, but only these two are squares. So we can combine these two by taking their coefficients and subtracting them. So 6 subtract 3 is 3, and then you aren't going to change the variable at all. It's just going to stay in x squared. So sometimes I'll see students subtract the exponents and do 2 minus 2 and do a power of 0. We don't want to do that. We just want to keep it at 2. And then this term is just a 4x. An x can't combine with an x squared, and it can't combine with a number. So we're just kind of stuck there. So we just keep it as a 4x, and we're just going to keep this as a plus 2. And then it's already going in descending order because our power is going at power of 2, power of 1, and then our number. So we're done. Okay, on this one we do have parentheses, but since it's just a plus sign, if I distribute a plus through, it's just going to stay the same sign. So I'm just going to actually drop the parentheses. We have 3x squared minus 4x plus 1, and I'm going to add the x squared. And then if I add a negative 6, it just is like a subtract 6. So now we're going to go through and find our like terms. And some kids I've seen, if you're a visual learner, you might like this method, but they'll take their like terms. So here's an x squared and an x squared, and they put them in the same shape. So if I have 3x squareds and 1x squared, now I can kind of visually see those need to go together. So 3 plus 1 is 4x squared. And then they would do like the x's next. So let's put those in a circle. So I have a negative 4x in a circle, but then I don't have any other x's. So that's just going to stay a negative 4x. And then maybe put your numbers in a triangle. and you see you have a 1 and then a minus 6. Well, 1 subtract 6 is negative 5. So you don't have to do that way, but if you are a visual person, that can just be an easy way to kind of see the difference between them. But we are in descending order already. We're going 2, 1, and then your number, and so that's your final answer. Okay, let's practice a few more. So on this one, when you have multiple variables in one term, they still have to match. So I have a b and a c to the power 4. The only thing that can combine with it is another bc to the power 4. So in this case, these do match perfect, so we're good to go. They're like terms. So you'll just take the coefficient, the 5, and then the minus 13, and combine those. So 5 subtract 13 is a negative 8, and then that variable combination is not going to change. It's just going to stay a bc to the power 4, and that would be your answer. Okay, on this next one, we have parentheses, and we actually do need to do something with them this time. Whenever you have a negative, you're subtracting this entire polynomial. So sometimes I have students who just subtract the first part, but this subtraction is also applying to the second term. So we need to distribute that negative through so that I'm subtracting the 4x, but then when I subtract the negative 1, the two negatives turn to a positive. So we really add 1. And then you can just drop the rest of the parentheses. So we have 3x squared minus 2x plus 3. So now let's combine our like terms. Here I have an x squared, but scanning through, there are no other x squareds. So we're just going to keep it a 3x squared. And then I'm just going to cross it off since we've used it. Now let's look at our x's. I have a negative 2x, but then I have a negative 4x. So these are like terms, so we can combine those. So negative 2 subtract 4 would be a negative 6x. So now we've used those, we can cross them out. And then look at your numbers. I have a 3 plus a 1. So 3 plus 1 is 4. And it's already descending. We're going x squared, x, and then our number. So there would be your answer. And then let's do one more where you have the subtraction to distribute through. So make sure you do that. It's going to end up flipping all of your signs so that we have a negative x squared. This negative and this negative will turn to a positive 2x. And then this negative times this positive will be a negative 3. And then we can get rid of these parentheses now. We have 3x squared minus 4x plus 1. And then let's do the x squareds first. I have a 3x squared, and I also have a negative x squared. So I can combine these two. 3 subtract 1. Remember, it's like there's a 1 here. 3 minus 1 is 2. So I have 2x squareds. So let's cross those out now. Let's do our x's. I have a negative 4x here, but then I also have a plus 2x. So negative 4 plus 2 is negative 2. So negative 2x. Let's cross those out now. And then I have a 1 and a negative 3. 1 subtract 3 is negative 2. And we're already descending, so we're good to go. Okay, the last little part I want to do is just practice using those classification names that we talked about at the beginning. So these terms right here where you classify it by degree and then by the number of terms. So remember, if it's a degree 1, we call it linear, degree 2 is quadratic, degree 3 is cubic, and then anything bigger than a 4 we just call degree and then whatever the number is. And then for terms, if it's 1 term we call it a monomial, 2 terms is a binomial, 3 is trinomial, and then 4 or bigger we just call a polynomial. So I'm going to write some in this little box here, this little table, and then we're just going to classify it by the degrees and the terms. So let's say I have 2x cubed plus 3x squared, subtract x plus 5. So to get the degree, you just look at the highest degree of the whole thing. The biggest degree is a 3. And what we call a degree 3 is a cubic. So try and think of these on your own as you're going. And then on the number of terms, we have 1 term, 2, 3, 4 terms. So if there's 4 terms, we just call it a polynomial. So remember, 4 or bigger, we just call a polynomial. And poly means many. Okay, let's try another one. Let's say I have 5x squared, subtract 2. So my highest degree is a 2. And do you remember what we call a degree of 2? Call it a quadratic. Should have made these boxes bigger. And then on this one, we have 1 term, 2 terms. So we call a 2 term a binomial. Hopefully these terms and this vocab is getting a little more familiar. Okay, let's do 4x cubed. So on this one, we only have one thing here. The highest degree is a 3. We call that a cubic. And then if there's only one term like this, we call it a monomial. And then let's do 2x plus 6. So the degree on this one, it's not written, but if it's not written, that means the degree is a power of 1. And if it's only a power of 1, we call that a linear polynomial. And then on this one, we had 1, 2 terms. So this would be a binomial again. And let's just do one more. Say I have x squared plus 5x minus 1. So the degree on this one is a 2. So this would be a quadratic. I'm just going to abbreviate. And we have 1, 2, 3 terms. And if there's 3 terms, it is a trinomial. So we have a quadratic trinomial there. And I think we'll just stop there because it's getting kind of long already. Just remember that if you need any extra help, please don't hesitate to reach out to me. That is what I'm here for. I'm happy to help you. You can email me or just message me through Canvas. We can set up a Zoom call or a Google Meet, work one-on-one if we need to. But your homework is just on Canvas. Go ahead and get started. And then please let me know if you need anything and have a really good day. See you later.